Good evening to everyone joining us. Today, we are stepping away from the daily headlines that dominate our screens. We are moving past the political shifts, the economic fluctuations, and the terrestrial concerns that typically consume our attention. Tonight, we turn our gaze not merely upward toward the comforting tapestry of the starlit sky, but into the profound abyss of cosmic horror. We are looking directly into a scenario that science has quietly calculated, yet the human heart instinctively rejects. We confront the ultimate question: what would transpire if a black hole, the most enigmatic and omnipotent entity in the known universe, were to lose its way and drift silently into the sanctuary of our solar system? Picture that precise moment. You are seated in the comfort of your home, bathed in the soft glow of warm artificial light. Yet, just beyond the thin veil of our atmosphere, a celestial order that has held firm for 4.5 billion years is under siege. The intruder is a guest that no one invited, a point of absolute darkness, invisible to the naked eye yet possessing the power to pulverize both the fabric of space and the flow of time. This is not a script from a distant science fiction fantasy. This is a rigorous mental exercise grounded entirely in astrophysics, a thought experiment designed to expose the terrifying fragility of the grand oasis we call home. We will traverse this cataclysmic invasion stage by stage. We will not shy away from the technical realities but will instead translate dry data into vivid, visceral imagery. We aim to comprehend the sheer magnitude of an object that cannot be seen, yet makes its presence known through the irreversible mutilation of reality itself. Let us begin by visualizing the antagonist. Black holes are the silent predators of the cosmos, born from the violent collapse of colossal stars. In this scenario, we are not discussing the supermassive monsters that anchor the centers of galaxies. We are tracking a stellar mass black hole, an object likely 5 to 10 times the mass of our Sun, or perhaps an intermediate mass black hole, a rare breed that bridges the gap between the small and the truly gigantic. Recent astronomical discoveries have transformed this from pure theory to frightening possibility. In the year 2022, astronomers utilizing the Hubble Space Telescope confirmed the existence of a rogue black hole wandering alone through the Milky Way, just 5,000 light-years away. These nomads are created when a dying star explodes in a supernova, and the resulting uneven blast kicks the core out of its orbit. It becomes a cosmic vagabond, hurtling through the interstellar void at speeds exceeding 100,000 miles per hour. Now, suppose one of these invisible wanderers, steered by the chaos of galactic gravity, aims its trajectory directly at us. Phase 1: the subtle tremors and mathematical detection. How would humanity perceive the approach of an invisible monster? A black hole, by its very nature, absorbs all light, rendering it optically undetectable against the black canvas of space. The first warning would not come from a visual sighting but from the delicate dance of mathematics and gravity. Our most advanced space observatories, such as the James Webb Space Telescope or the future Nancy Grace Roman Space Telescope, would be the first to sound the alarm. Astronomers would initially detect inexplicable anomalies in the movements of distant objects residing in the Oort cloud, the vast shell of icy debris that envelops our solar system at distances thousands of times farther than Earth is from the Sun. These frozen sentinels and lonely asteroids would begin to drift into impossible trajectories, stretched and warped by a phantom gravitational hand. This phenomenon is known as gravitational microlensing, where the gravity of the black hole bends the light of stars behind it, creating a momentary, ghostly magnification. Inside the control rooms of space agencies, the atmosphere would turn heavy with dread. Physicists and engineers would stare at screens displaying chaotic data, their initial confusion rapidly freezing into terror. They would realize that a massive object is traversing our domain, yet it emits no heat radiation and possesses no spectral signature. It is simply a void of distortion. Supercomputers would run simulations at frenetic speeds, decoding the faint but consistent gravitational waves. The conclusion would be cold and undeniable: a black hole is incoming. At this stage, it might still be hundreds of thousands of astronomical units away, a distance that seems infinite to us, but in the grand scale of the cosmos, it is a bullet seconds away from impact. Phase 2: chaos in the Oort cloud and the Kuiper belt. The Oort cloud acts as our first shield, a vast reservoir containing trillions of icy remnants from the dawn of the solar system. As the black hole glides through this region, its mere gravitational shadow triggers a cosmic earthquake. Billions of icy comets would be violently ejected from their slumber. This would not be a gentle meteor shower. It would be a torrential flood of celestial debris. The black hole would act as a gravitational slingshot, hurling these objects toward the inner solar system at velocities that defy imagination. On Earth, observatories would record a sudden, exponential spike in incoming near-Earth objects. Anxiety would curdle into global panic as trajectory models predict impacts far more devastating than the asteroid that extinguished the dinosaurs. Major metropolitan areas and entire nations could be erased in the blink of an eye, not by the black hole itself, but by the shockwave of debris it pushes before it like a snowplow. Phase 3, the dismantling of the gas giants. As the intruder presses deeper, it begins to toy with the guardians of our system, Jupiter, Saturn, Uranus, and Neptune. These gas giants maintain the delicate gravitational balance that protects Earth. If the black hole passes near Jupiter, the tidal forces, which are the difference in gravitational pull between the near side and the far side of the planet, would tear the planet apart. The structural integrity of Jupiter would fail. The pressure and temperature within its core would spike dramatically, potentially triggering unstable nuclear reactions, turning the planet into a glowing, doomed reactor. Winds, stronger than any hurricane ever recorded by a factor of millions, would rage across the planetary system. We might witness the Great Red Spot unravel into a chaotic ribbon of gas, stripping the planet of its majesty. Phase 4, the approach of absolute darkness. When the black hole breaches the orbit of Neptune, time runs out. The orbits of Neptune and Uranus would be destabilized instantly. They could be flung into deeply elliptical paths or ejected entirely from the solar system, destined to wander the void as rogue planets. The debris from their shattered rings would add to the deadly shrapnel storm heading toward the inner rocky planets. The most critical threat is the destruction of orbital mechanics. If the black hole passes anywhere near the Sun, it will elongate the orbits of all planets. Earth would be cast into a highly elliptical orbit. We would experience summers that scorch the surface to molten glass as we swing too close to the Sun, followed by winters of absolute zero temperatures as we are flung into the deep darkness. The delicate biosphere that supports human civilization would collapse almost immediately. Phase 5, spaghettification and the distortion of reality. When the black hole reaches a distance of roughly 100 astronomical units from Earth, the effects become physical and terrifyingly personal. We enter the realm of tidal heating and spaghettification. The tidal forces would begin to stretch the planet Earth. The side of our world facing the black hole would be pulled with significantly greater force than the side facing away. Tectonic plates would be ripped asunder. Earthquakes of magnitudes never before seen on the Richter scale would shatter the crust continuously. Supervolcanoes would erupt simultaneously across the globe, choking the atmosphere with ash and blocking out the sun. Oceans would rise in tsunamis kilometers high, sweeping over continents and erasing all traces of civilization. The sky would turn a blood red, illuminated only by magma and lightning. Our moon would likely be ripped from its orbit, either torn to pieces to form a glowing ring around the black hole or flung into the depths of space. If it is torn apart, the debris would rain down upon us like thermonuclear warheads. Phase 6, the final interaction with the Sun. If the black hole grazes the Sun, passing within just a few astronomical units, our star would be deformed into the shape of an egg. Superheated plasma would be siphoned off the surface of the Sun, creating a river of fire flowing directly into the maw of the black hole. This transfer of matter would form an accretion disk around the black hole, a swirling halo of doomed matter spinning near the speed of light. This disk would shine with a brilliance that outshines the Sun itself, emitting lethal blasts of X-rays and gamma rays. These beams of radiation would sterilize the Earth, frying our atmosphere, destroying the ozone layer, and instantly incinerating all electronic grids and biological life. We would witness the Sun being bent into an Einstein ring, a halo of light warping around a center of perfect darkness, the final visual proof that we are facing an entity that dominates space-time. Conclusion: the two final scenarios. Ultimately, two fates await us. In the first scenario, Earth is ejected from the solar system. We become a rogue planet, drifting alone in the dark. the sun becomes just another distant star. Our oceans would freeze down to the bedrock, and the atmosphere would turn into snow, falling to the ground. Life would extinguish in the eternal, frozen night. In the second, more violent scenario, we are consumed. In a matter of minutes, the Earth would be stretched into a long, thin strand of atoms, superheated to millions of degrees, and pulled across the event horizon. We would vanish from this universe forever, leaving no trace that we ever existed. Even if the black hole misses us and we miraculously survive the passage, the solar system would be unrecognizable. The planets would be on new, chaotic paths. The asteroid belt would be scattered. We would face centuries of bombardment. Why do we engage in this terrifying visualization? We do so because it is the ultimate test of our understanding of gravity and physics. It serves as a humbling reminder that we reside on a fragile island of stability amidst a universe that is cold, vast, and indifferent to our survival. Against a rogue black hole, we are utterly powerless. No weapon, no technology, and no strategy could save us. Yet, it is precisely this powerlessness that should inspire us. It compels us to cherish every moment of sunlight, every day of stability that our Earth provides. The problems we create for ourselves, such as climate change, petty wars, and environmental destruction, seem insignificant when juxtaposed with the true threats of the cosmos. Therefore, we continue to look up at the sky, not with fear, but with the profound realization that life here is a miraculous anomaly that demands protection with all the wisdom and unity humanity can muster. Thank you for joining me on this haunting journey through the dark.